When we started down the path of hearing loss research, we wanted to focus on targeted sequence capture, a limited number of genes, and we wanted to partner with industry because nobody had made a platform for any disease indication. We partnered with Agilent. Doing this is huge because we help people not just here in Iowa and not just the people who come to see me, but we have a global outreach.
It is amazing how technology has changed the way we do science. The Agilent ShareSelect targeted genomic panel made it really easier and faster for us to identify novel genes, to identify novel variants, to solve some of the mysteries that for a long time surrounded some of the aspect of genetic hereditary hearing loss.
One of the things that we like about custom capture with ShareSelect is that we can really comprehensively cover our genes of interest to make sure that we're covering intronic regions or promoter regions that we might be interested in.
Using our hearing loss panel, we've been able to identify novel mutations that lead to hearing loss. We've been able to reclassify variants that were previously thought to be pathogenic to benign. We've also been allowed to unravel the genetic underpinning associated with deafness in specific populations.
There's other pieces of the genes that we've identified as being important. So certain genes, there's deep intronic variants that have been shown to cause genetic hearing loss. And so we want to make sure that those are really well covered.
The targeted capture approach allowed us to evaluate more samples at one time, pool more samples in one pool, and evaluate more subjects at one time with a lesser cost.
The platform is really, really powerful. We can detect CNVs, or copy number variation, that involves a single exon, whether single exons dropped or duplicated, plus really large copy number variants.
So what we're learning is that there are genes that have copy number variation that are very frequent as causes of hearing loss. And we didn't know that before because of some of the techniques and the limitations that we were using.
We meet weekly. It's a multidisciplinary meeting, gathering clinicians, scientists, geneticists, bioinformaticians, and genetic counselors. And we study each individual at a time, looking at their genotypic data, looking at their phenotype. Having all this information at hand help us actually decide and make a final call on whether any of those variants is related to the hearing loss in this individual.
So we are exploring right now using the same platform, but phasing the data and then asking, do common variants have subtle effects over the lifetime of a person? Do they contribute to noise-induced hearing loss? Do they contribute to age-related hearing loss? And we have good data that they do, and we're in the process of validating that in large populations. Lots of exciting things to do and endless possibilities and lots of dreams to realize.